We needed more power in electrification, or in the electric motor, if we only had one motor, so hence we came up with dark matter. Imagine a world where machines move so fast and think so efficiently that they no longer feel like machines at all. A world where electric power and mechanical force blend into one seamless flow of energy that seems almost alive. In this world, the boundary between old technology and new ideas fades until it becomes hard to tell where combustion ends and electricity begins. It is a place where engineers chase dreams that look impossible and then somehow turn them into real things you can touch. And in this evolving landscape stands one company willing to push deeper than anyone else into the unknown. Koenigsegg, the Swedish master of speed and innovation, has stepped forward once again with something bold, strange, and unlike anything the automotive world has seen. Their new electric motor, known as dark matter, is wrapped in mystery and packed with ideas that break traditional rules. It is small, light, powerful, and almost frightening in its potential. Today, we enter the core of this creation, exploring how it works, why it matters, and how it changes the future of hypercars. So tighten your seatbelt because the secrets inside this machine might shift how you see electric power forever. Koenigsegg recently revealed the final production version of the Gemera hypercar. At first glance, it looks like a mix between a spaceship and a land-based rocket, but its design is not the biggest story. Beneath the surface sits a hybrid system that is far more complex than a typical performance car. Instead of using one combustion engine and one electric motor, Koenigsegg decided to be different. They combined two combustion engines with a single electric motor so advanced that it feels like something engineered for another decade. They call this motor dark matter, a name that almost dares you to imagine forces you cannot see. And honestly, this name fits because once you learn what it can do, you start to understand why Koenigsegg treats it like a breakthrough. The first thing people notice is how it looks. Instead of a chunky metal housing or a bulky aluminum shell, the motor is wrapped in forged carbon fiber. It looks sharp, futuristic, and almost artistic, but the design is not just for looks. That carbon structure helps make the motor incredibly light. It weighs under 40 kilograms. For comparison, many electric motors with far less power can weigh almost double. But dark matter is not just light, it is strong. It is built to withstand huge loads and extreme speeds without warping or failing, and the performance numbers prove it. Koenigsegg says this motor produces 800 horsepower and 922 pound-feet of torque. Those numbers are insane for something this small. They belong in the realm of full engines, not something that you can lift with one arm. The secret behind this power begins with the six-phase design. Most electric motors used in cars are three-phase. That means the stator uses three sets of coils to control the rotating magnetic field that turns the rotor. It is efficient and reliable, which is why almost the entire EV industry uses it. But Koenigsegg wanted more. By using 6 phases, they double the number of electrical circuits driving the motor. This spreads the load and reduces heat. It allows more current to flow without overloading any single part of the system. It also increases control. With more phases, the motor can fine-tune magnetic forces at very high speeds. This means smoother operation, less vibration, and stronger torque delivery. Many engineers believe that a 6-phase motor inside one housing behaves almost like two motors sharing a single body. That might be part of how Koenigsegg achieves such extreme output. We do not know the exact internal layout because Koenigsegg keeps its secrets, but we can study similar systems in other high-power vehicles. For example, Ford's Supervan uses a 6-phase machine to reach almost 2,000 horsepower. The idea is the same. More phases equal more power capacity, more phases equal safer current distribution, and more phases mean more stability at high RPM. Koenigsegg uses all these advantages and then builds on them with exotic materials and bold engineering choices. Now, let's move to the axial flux part of the design. This is another area where Koenigsegg chose a path different from most car companies. Standard EV motors are radial flux. In those motors, the rotor sits inside the stator like the hole of a donut. The magnetic forces push and pull outward and inward. But axial flux motors look more like stacks of flat disks. The stator coils face the wide surfaces of the magnets, not their sides. This changes how the magnetic field flows. Instead of moving radially, it moves axially. That difference creates several advantages. So, axial flux motors can actually be thinner, which is pretty cool. They also manage to pack more torque into a smaller space, plus they're often more efficient at low speeds, and they allow for better cooling pathways. Now Koenigsegg really loves compact designs, because, a smaller size means less weight, and less weight translates to faster acceleration and stronger performance. So honestly, the axial flux layout fits just perfectly into their engineering style. Anders Zachrisson, who leads Koenigsegg's electric motor development, explained that the company always looks for ways to cut mass without losing strength. To achieve this, they used advanced aerospace-grade materials. One of the most important is 300M steel. This steel is used in aircraft landing gear and other critical flight components. It's vacuum melted for purity, and it contains silicon, vanadium, carbon, and molybdenum for high strength. By using this metal for the shaft, Koenigsegg ensures the motor can handle extreme stress while staying compact. The rotor design is even more impressive. Koenigsegg built it using its air-core carbon fiber technology. Instead of using a solid iron core which would add weight and cause magnetic drag, they made the rotor hollow. That hollow design reduces mass and allows higher rotational speeds. It also reduces losses caused by eddy currents. When combined with powerful permanent magnets and direct cooling, the rotor becomes both efficient and incredibly strong. Direct cooling is another important part of the motor. Instead of cooling the outside casing and hoping heat slowly travels outward, Koenigsegg places coolant near the stator windings themselves. This pulls heat away instantly. It allows the motor to operate under heavy load without overheating. And, because axial flux motors are thin, cooling pathways can be more effective compared to traditional radial designs. When this motor joins forces with the twin-turbo hot V8, the result is shocking. The combustion engine alone produces 1,500 horsepower. When dark matter adds its 800 horsepower, the total climbs to a staggering 2,300 horsepower and over 2,000 pound-feet of torque. These numbers do not feel real. They place the Gemera in a category beyond most hypercars. Christian von Koenigsegg even said that the Gemera HV8 is the most powerful production car on Earth, yet it remains practical and, honestly, surprisingly easy to drive. That combination of power and usability comes from careful engineering and the seamless blend of electric and combustion energy. Some experts believe YASA, a British company known for axial flux motors, influenced Koenigsegg's development. YASA has worked with Koenigsegg before and also supplies motors to Mercedes. Because axial flux is still a new technology for the automotive world, many people try to guess exactly how dark matter works. One theory suggests the stator might use U-shaped coils arranged in a torus-like pattern. The rotor would sit inside these coils with magnet sets facing different sides of the U-shape. This would allow three magnetic surfaces to work together, multiplying torque. Another idea is that Koenigsegg increased the diameter of the rotor relative to the stator. A larger rotor creates more leverage, which increases torque, and more torque at higher RPM leads to more power. Christian von Koenigsegg hinted at this idea in an interview, mentioning that increasing rotor diameter against stator bulk allows more magnetic flux to move through the system. Even though we can't see inside the motor, we know enough to understand the direction Koenigsegg is moving. They want maximum magnetic efficiency, maximum power density, and minimum weight. They want motors that feel alive, motors that respond instantly, motors that make electric performance feel thrilling instead of expected. As hybrid and electric technology grows, more exotic designs like this will appear. Companies working on hypercars will experiment with unusual layouts, creative materials, and new cooling solutions. Koenigsegg is simply ahead of the curve. The future of hypercars will not choose between combustion and electricity. It will combine them in ways that give us the strengths of both. Hard mechanical force will merge with silent, instant torque. Lightweight materials will merge with powerful magnets. Smart cooling will merge with advanced software, and motors like dark matter will lead the way. The road ahead will be fast, strange, and full of ideas we once thought impossible. Koenigsegg is showing the world that the next chapter of automotive performance will be built with imagination,